Alright, welcome to a video on independent and dependent events. This is another thing that I struggled with when I was in school. Had to work really hard to try to get it, and it's still one of those things that I struggle with. So if you see a mistake, let me know. I've already gone through this a couple times because I noticed that I can't spell. That doesn't really have to do anything with the math, but if you don't spell something right or you don't put the right letter somewhere, it makes a problem impossible to do. So, let's see if we can get through this without me seeing that I made another mistake with spelling. So we're going to start with independent events. So an independent event is when one event does not affect another event. So you have two things that are going on and they have nothing to do with each other. So like if we're rolling two dice, we're recording the results. So if you roll one dice and then you roll another dice and you're just trying to write down what the numbers are, those are independent events. They don't affect each other at all. One happens, the other happens. Dependent events, though, is when one event does affect another event. So let's say there's two people choosing team members from a set of 10 people. Like you have two team captains picking their teams. If the first person picks Johnny, that means that the second person can't pick Johnny because they're already on the other team. They have to choose from the 9 remaining. So what the dependent events are kind of seen as like, okay, is something taken away the second time we do something? With independent events, we're not taking anything away. Dependent events, we're taking something away and we can't use it for that next thing. And then we have this thing called conditional probability, and this works with dependent events. So it's the probability that event B occurs given event A occurs first. So we're trying to figure out if something else happens, what will it be if we know this other thing happened first? So this is again the replacing thing. So for example, we have a school of at a school 20% of the students are in choir and 5% of the students are in choir and art. And we want to try to find out what's the probability that a random student is being in choir and art. So to do that, we are going to do the conditional probability, which is the probability of A and B divided by the probability of A, the first event. So we're going to explain more what the top of this means later. But what this basically means is that what's the probability that this happens divided by the probability that A happens first. So we look how many students percentage-wise are in choir and art. Well, that is 5, and I'm not going to do percent. I'm just going to assume everything is out of 100. So we have 5 students that are in choir and art, divided by the total number of students that we have there, the probability of that first event. So that first event is 20. So we see that it's 5 out of 20, which we simplify to 1 divided by 4. So the conditional probability of that is 1/4, or 0.25, or 25%. Okay. So let's talk about the probability of independent events. And this is a long old definition here. So let's take a deep breath and do it. Two events, A and B, are independent if and only if the probability that both events occur is the product of the probability of events. So this probability of A and B. So we're seeing the probability of A and the probability of B. We're trying to figure out these two things. When they're independent, we take the probability of A times the probability of B to see what the probability is that they both occur. So we're going to take the probability of the first event times the probability of the second event, and that'll tell us the probability that both events happen. So you're taking a multiple question test, so multiple choice test. On 2 questions you guess from the 4 choices. What is the probability of getting both right? So our 2 events are guessing on a 4-choice multiple choice question. So in order to find the probability of A and B, we have to find out the probability of A and multiply that with the probability of B. So the probability of A. There's 4 choices, so that's going to go on the bottom. There's 4 choices. One of them is right. So that's that one that we want to see if we can correctly guess. And then we do the probability of B, which is the same thing, 1 out of 4. So if we guess, there's a 1 out of 4 chance that we're going to get that right. And then to figure out this total probability, we take that 1/4 times 1/4, and that gives us 1/16. So the probability that we were to get them both correct is 1 out of 16, which we can again change to a decimal. There's my calculator, which is 0.0625 or 6.25%. Okay, so now we're going to do the probability of dependent events. This one's even longer than the last definition. So if you have 2 events, A and B, that are dependent, then the probability that both events occur is the product of the probability of the first event and the conditional probability of the second event given the first occurs. So the probability of A and B occurring with a dependent event is seen as the probability of A times the probability of B given A. So that slash means A, given. So let's just do an example here. So we have a bag containing $21 bills and 5 $100 bills. You are going to randomly draw a bill and set it aside. Then randomly draw a second. What is the probability both bills are $100? Now, the key thing here is recognizing that it's dependent is by looking at this set it aside thing. We're not replacing it. So anytime you see like replacing, that means it's probably an independent event. If it's not being replaced, if it's being thrown away, set aside, not put back in the bag or the box, whatever it is, then it's most likely a dependent event because we've now changed the number of objects that we are choosing from. So we're going to find out the probability that A and B occur, and that's going to be the probability of A times the probability of B given A. So A is our first event, B is our second event. So the probability that the first event occurs, what we're going to do is we're going to take all of our total choices on the bottom. So there are 25 bills. And then on top of our fraction, we're going to have what we're wanting to get. And we're wanting to get a $100 bill, and there are 5 $100 bills. So 5 out of 25 is our choice. And you can simplify this to 1/5 as well, and I'm going to actually do that just to make it easier. So there's a 1 in 5 chance that we would get a $100 bill. Now we're going to figure out the probability of B given A happens. So this isn't as complicated as I think I probably made it seem the first time we did it. We're just going to think through this. Okay, so we had 25 bills. We took one out and set it aside. Now instead of having 25 bills, we have 24 bills to choose from. And since we are assuming that that bill we took out was a $100 bill, we now no longer have 5 $100 bills, we have 4 $100 bills. So that now turns into 4 out of 24, which can be simplified to a 1 out of 6 chance. And that's what we're going to put here for our conditional probability. So if it seemed like it was a lot more complicated the first time around, it really isn't. You can pretty much think through most of these. So now we just do the multiplication. 1 times 1, 5 times 6. So there's a 1 out of 30 chance that that happens, which can be changed to 0.03 repeating, or a 3.3% chance. So we can say that if we wanted this to happen, if we wanted to choose $200 bills, there's a 3.3% chance that would happen. So that's our video on independent and dependent variables. Go ahead and try some practice problems.